Welcome back, class. If you want to go ahead and turn your books to page 371, this is lesson 5.1, lines. We're going to be talking about exactly what the topic is, very simple concept, just lines. So, two main type of lines that we deal with a lot in math are what we call perpendicular lines and parallel lines. Basically, when two lines intersect in a plane, just meaning, a plane is just a flat surface, and form right angles, they are called perpendicular. So when two lines meet and make right angles, those are called perpendicular lines. And under the draw it here, I'm going to do that part first. Basically, perpendicular lines, think of a street intersection, one line there, one line here. And then, I'm not a perfect artist, so my lines aren't perfect, but the way we can know that those are exactly right angles is the little box in the corner meets, and that tells us, hey, that's 90 degrees, so all the other ones are 90 degrees. The other type of lines we deal with a lot are when two lines are called parallel lines, when they are in the same plane, meaning same surface, and never intersect. Intersect simply means meet. So here these meet, form 90-degree angles. Example of parallel lines are just two roads. I usually think of roads when I think of these. They're two lines, two roads that just simply will never meet. They're just running side by side forever. So what you need to do right now on your own is define these two in your own words. So in your own way, describe what parallel lines are, and in your own way, describe what perpendicular lines are. Okay? Now, describe a real-world example of it. I used roads, so I'm going to put roads here. You need to come up with a different idea. Okay, I don't want to see roads written on yours. You need to write something else. Okay. It says a gymnastic event in the Summer Olympics involves the parallel bars. So here you have a person on the parallel bars. The women compete on uneven parallel bars, and the men compete on the parallel bars. Like the one shown. Circle the parallel line shown in the photo to the right. So we're looking here at all the different parallel lines that we may see. We actually see his feet are going parallel, his arms are going parallel, and then the bars themselves are parallel. So pretty basic stuff. Now we're getting to the less basic stuff. On this page you will see like half your vocab list, okay? We have vocab words on top of vocab words here. We're just going to underline a couple of them. And basically, you don't need to be overwhelmed by these. Just think about what the words mean. Okay? If you just think about what the words mean, they're much less intimidating. The first word, however, is a word you kind of have to learn. Transversal. I would just underline here. It says a line that intersects two or more lines is called a transversal. So transversal, I would underline here or highlight. A highlighter would be great if you had a highlighter. Would just be intersects. A transversal intersects two or more lines. That's what you need to know about a transversal. Transversal is this line here. It crosses, it intersects at least two other lines. Okay. Now, interior angles. Interior. Think of like the interior of a house. If I say, hey, we're in the interior of a house, what does that mean? It simply means we are inside. So underline inside. The interior of this is angles 3, 4, 5, and 6. This is the interior of the two lines. It is inside the two lines. Interior of a house simply means inside. Now exterior angles, the exterior of a house or the exterior of something is simply the outside. So underline outside. So if these are in the inside between the lines, which angles are on the outside? Angles 1 and 2 are on the outside this way, and then 8 and 7 are on the outside this way. So exterior, outside, interior, inside. Now, this word here, alternate. If you're an alternate on a sport team, it means like you're the other person, okay, or other side. So an alternate interior simply means like the other one or really the opposite. If things are alternates, they're sometimes also considered opposites. So alternate interior angles simply mean interior, inside angles that are opposites. So for example, 4 and 6 here, these are interior, so they're on the inside, and they're on opposite sides. So 4 and 6, notice they're about the same degrees, so they are alternate interior angles. They are alternate each other, meaning they kind of take the place of one another. If they're an alternate, they're on opposite sides, but they're on the inside, so they're alternate interior. The other alternate interior angles are 3 and 5. So 3 and 5 are similar, but they're on alternate opposite sides and on the interior. Now the next one is alternate exterior. Well, exterior here means outside, so you're dealing with outside angles. Alternate on opposite sides. So you're looking at the outside. Now what are the opposite angles on the outside? Well, 8 and 2 are on opposite sides of the transversal, and they're on the outside. So those are alternate exterior angles. And then 1 and 7 are on alternate opposite sides, and those are also on the exterior. Okay? Corresponding angles are those angles like in the same position. Okay? So I would underline here, same position. Corresponding angles are basically the same angle in the same position. The first example it gives you is 1 and 5. So if you look at this intersection here where these meet, the angle up and to the left is 1. Then if you go down here where the intersection is, if you go up and to the left, it's 5. So 1 and 5 are corresponding, meaning same angle, same placement. So the corresponding angle to angle 3, you go to the intersection, angle 3 is down and to the right. Then from here you go down and to the right, and you end up with angle 7. So we see here angles 3 and 7 are corresponding angles, meaning same position, same place, same degrees. They pretty much basically match each other. Okay? So let's take a look here. It says classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. Okay? So here it says 1 and 7. Well, let's first look here. Are 1 and 7 on the inside, or are they on the outside? It's on the outside, so we know they're exterior. Then we look, okay, are they on the same side or opposite sides? They're on opposite sides, so we know they're alternate exterior angles. 2 and 6 are on the 6 is on the inside, 2 is on the outside. So this tells me they're in the same place, same position. They're both kind of to the right of the intersection. So these would be corresponding. Now let's look here. Classify the relationship between 4 and 6. So let's actually look at 4 and 6 here. What do we know? Well, 6 here is on the inside, so we know it's an interior. 4 is also on the inside, so we know it's on the interior. So then we also see, here's our transversal. They're on opposite sides, so we look at the word opposite. That's our word alternate. Okay, and they're on the inside, so alternate interior angles. And I would say because they are on the inside and on opposite sides. Okay, so that's basically explaining then what alternate and interior mean. That's the justification. That's the explaining you should do. Okay? Now we're going to talk about finding missing angles here. Okay? It says when parallel lines are cut by transversal, which is what we're dealing with here, special angle relationships exist. If you know the measure of one of the angles, you can find the measure of all the angles. So just one angle will give us all of the rest of these, okay? Suppose you know that the measure of angle 1 is 50 degrees. Can you use that to find the measure of angle 2, 3, and 4? Well, basically what I do, and since you can write in your book, I would write this stuff in. So we know this is right here is 50 degrees, okay? So angle 1 is 50 degrees. Well, a straight line right across here, a straight line is 180 degrees. So if we know a straight line is 180 degrees, this takes up 50 of it, okay? So to find angle 2, we simply take 180, meaning a straight line, subtract 50, and you're left with 130, which is what it tells you right here. Okay, so we know angle 2 is 130 degrees. Okay, now we know from all of our vocab here that alternate interiors are the same, alternate exteriors are the same, and corresponding are the same. So I usually start with the corresponding. Which angle is in the same place as angle 1? Well, that's angle 5. So that's 50 degrees. You can just kind of start filling them in. Then I go, okay, which angle is kind of up and to the right? Here is angle 2. Down here, the one up and to the right is 6. These are going to be the same. So that's 130. Alrighty. Now alternate exterior, meaning outside. 2 is on the outside. So which one is on the outside down here? Opposite of it. 130. Then the alternate exterior there is 50. Then we can do alternate interiors. So 6 is 130, which means 4 is 130. And then 5 is 50, so that means 3 is 50. Okay? And you can fill all those in. Let's do that with exercise, example 3. It says a furniture designer built a bookcase shown. Line A is parallel to line B. It says if the measure, that's what M means, it stands for the measure of angle, that symbol's angle 2, so the measure of angle 2 is 105 degrees. So I'm going to go to 2, I'm going to write in 105. Okay? Find the measure of angle 6 and the measure of angle 3, justify your answer. Okay? Justify can mean an explanation or work. So I'm looking for 6 and 3. So this one here and that one there. So I'm going to find this one here because I see a straight line right here. I know a straight line is how many degrees? 180. You may want to write that down in your notes somewhere. A straight line is 180 degrees. So here we have 105 of that in angle 2. So I'm going to write 180. I'm going to subtract 105. And that leaves me with 75 degrees. Oh, that degree symbol should be on the back side, not the front side. So that's 75 degrees. This is my work, so I'm going to put the M, the measure of angle 6 equals how many degrees? 75 degrees. Okay, that would be correct work and justification. Now, I would say then the measure of angle 3 equals, how will I find this one? Well, these are alternate interior angles, 6 and 3, so it's going to be the same as this one. But this one doesn't require math to justify. You actually have to explain in words because angle 3 and angle 6, oops, I wrote 3 again, are, and you have to use the right words, what are they? Alternate interior angles. Alternate interior angles and are the same. Okay, so you need to tell me what they are, and then that means that they're the same. Now refer to the solution above to find the measure of angle 4. So I'm looking at angle 4 here. How in the world would I find angle 4? Once again, you have a straight line up and down here. Okay, straight line, how many degrees? 180. We already know from our previous answer 3 is 75. So to do our work, we do 180 minus that 75, and we're left with 105 degrees. So you could say the measure of angle 4 equals 105 degrees. Or you could have explained it in words and said that 2 and 4 are corresponding angles. And corresponding angles, if you look back over here, corresponding angles you know are the same amount. So there's more than one way to necessarily solve some of these. You just kind of have to think creatively and know what you're talking about, which I know sometimes can be tough, but you know, we try our best. So you could do your math here, or you could explain in words. Make sure you have all that work shown. Me and Miss Neely are going to be checking it. Okay, last example. Wow, look at this one. This can be scary and intimidating, but as long as you kind of follow the steps, you will be fine. It says in the figure, line M is parallel to line N, and line Q, which is this one here, is perpendicular, meaning 90-degree angles, to line P, this one here. The measure of angle 1 right here is 40 degrees, so I'm going to write that in. Okay, that's 40 degrees. What is the measure of angle 7? So we're looking for this one right there. Well, this is a whole lot of tricky, but you just got to follow the steps, all right? What we see here is that this transversal cuts through here, which means that angle 1 corresponds to angle 3, okay? Notice, kind of up and to the right, up and to the right. So angle 3 is also 40 degrees, okay? Now don't let the rest of the stuff scare you. You know that's 40, so you know that's 40. And then you see a straight line. Well, on the previous pages, when we dealt with the straight line, we just had to subtract one number here, okay? But on this page, notice what happens. We know we have a straight line here, so we know the total is 180. Well, this takes up 40 of it, so we subtract 40. Then this little box here means 90 degrees, so that takes away 90, so we take away 90. Okay? Then whatever is left over is angle 7. So if we subtract 40 from 180, we're left with 140. Then if you subtract 90, you're left with 50. So angle 7 is 50 degrees. Okay? And this here, read this explanation. It kind of talks about the same type of steps, but just in a slightly different way. And there's more than one way to do these problems. You just kind of have to know the connection between all the different angles. One thing I want to point out for your homework, this shape here was nowhere in our examples, but you need to find the missing angle here. What me and Miss Neely recommend you do is take a ruler on this one and extend the line. And then you have shapes very similar to what we've seen. You have two parallel lines cut by this transversal, and you can do it that way. All right? If you have any questions, bring them tomorrow to class.